AWS CloudFront Service and Architecture. We started this module with a discussion on what CDN is, what a CDN service is made up of, and then we looked at the CDN service capabilities. What are the different services, features that a CDN provider, a managed CDN provider or platform CDN provider would offer? Now it's time for us to look at a CDN provider in practice. For that, we have chosen AWS CloudFront. Let's look at the service and its architecture. So what are the objectives? We will look at what CloudFront is, what the features of CloudFront is, the usage patterns for CloudFront, AWS service integrations, and then we will look at the architecture. That's where we're going to be spending a lot of time. Configuring the CloudFront service to deliver content. What does it take to do that? And then delivering the content to users. How does CloudFront deliver the content to the users? We'll look at the last two from a flowchart perspective so we can see how the data is flowing from the origin to the edge site to the end users and back all the way. So what is CloudFront? CloudFront is a CDN. It is a managed platform as a service, CDN service. It's used for fast distribution of static content, which is your images, style sheets, PDF documents, and also dynamic document. Dynamic document is your shareable document, which is also used for distributing your videos and audio files, which are streaming, but they are still considered to be static documents. Content is served with low latency to the end users because the content is close to the end users. Also, the edge site locations transfer the data with high data transfer speeds. That's because AWS has edge servers all over the world, and they have teamed up with local ISP providers to serve content fast. And it's delivered to the end users using a global network of edge locations, which are your edge servers in the edge locations. There is no upfront cost, it's pay-per-use offering. If you look at many of the CDN providers, you have to go through complicated contracts. So what are some of the features? There's a management console with which you can point and click and create your Amazon CloudFront distribution. You don't really have to write any code at all. Dynamic content, it delivers dynamic content, including the dynamic portions of your website that change for each user. They allow you to define static content to be shareable content that allows you to bring in dynamic content. And you can say, I want to serve this particular content only to this particular user, and I can still use CDN for that. Support for post, put, and other HTTP methods. Most CDNs only give you support for get, to only get the content and serve the content. Here they are also supporting post and other HTTP methods like delete. Custom SSL. If the CDN is going to be serving content on behalf of you, they should be able to serve the content using SSL. But then if you're going to be serving under your domain, they should be able to pick up your domains using CNAMEs and serve secure content over HTTPS using your custom domains, which CloudFront does. Invalidation. CloudFront can remove copies of a file from the CloudFront edge locations if you want to. Now they do charge you for that, but it's possible for you to do that. Wildcard CNAME support. CNAME is canonical name. If you want, you can use wildcards for that. So for example, you can say star.mydomain.com. You can say that rather than saying images.cdn.mydomain.com or videos.cdn.mydomain.com, you can simply say star.cdn.mydomain.com, and then they would basically use that one CNAME to serve all the contents for you. If you don't understand what it is, don't worry about it. For this you need to understand domain names and CNAMEs and DNS, a little bit more detail. But the important thing for you to remember right now is that they actually support the wildcard CNAME concept. Device detection. The edge locations can look at the value of the user agent, which has information as to what type of a device it is. Is it an iPad? Is it an iPhone? Is it an Android device? Is it a desktop? Is it laptop? Is it a tablet? All that information is there in the user agent. and the CloudFront edge sites identify those things and report on those things. You actually get reports in your console. Geo-targeting. It is possible to detect the country where the end users are coming from, and you can do that based upon the IP address from which they're making the request. So geo-targeting is possible, and it's also possible for you to serve content only to certain countries. Cross-origin resource sharing, which is called CORS. This is really an idea where CloudFront can be actually configured to forward the origin header value so that your origin server can support the origin access via CORS. Now, if you do not know what CORS is really a mechanism by which you can have cross-site scripting, not cross-site scripting in terms of security attacks, but there are certain situations where cross sites need to communicate with each other using the scripts. If you don't know much about CORS, you might want to look into that. The important thing to remember is that when you have a CDN service where your dynamic web page is using CDN content, and it's not only using CDN images and style sheets, it's also bringing in JavaScript, there are certain things that need to work right. If you don't have those things working right, you're not going to be able to do your cross-site scripting. So there are things that you can actually put in your CDN site. There are these cross-origin XML files that you can put in there that allow you to do cross-origin resource sharing. And that's what this support is all about. Again, if you don't understand too much about this, don't worry about it. I just want to make sure you understand that such features are available as part of CloudFront. Forward HTTP headers to the origin. When the HTTP request is coming to the edge site, it should be able to forward that information to the origin. Load TTLs. The edge servers are serving content to the end users, and in many cases the edge servers are actually caching the content. You can cache the content for a specific amount of time, and what this is saying is that you can have your cache to be as low as 0 seconds. Now you might ask the question, hey, why would I want to use CDN when I don't have anything to cache? Well, later on in the section on architectural capabilities, I'm going to show you how using a CDN in a completely dynamic site still helps, because you can actually take advantage of what is called TCP slow start. Support for cookies. You can specify whether you want the Amazon CloudFront to forward the cookies to your origin server, and if so, which ones. They'll go ahead and forward those cookies. There's also support for query strings. You can also forward the query strings. For example, you may have a URI that says /dir1/dir2 question mark size equals 45. When you have question mark size equals 45, it's what we call query parameters. Those query parameters can also be passed to the origin server. Reporting. It provides all kinds of reports: cache statistics report, popular objects report, usage charts, and access logs. Custom error response. Sometimes the client may ask for an object that is not a valid object. In that case, it may return a 404. And if it has to return a 404, you can explicitly say what kind of you can actually customize that particular HTTP 404 or HTTP 401, which is an authentication error. Those responses can be actually customized. Security. You can have custom SSL certificate. You can also serve private content. And Amazon CloudFront is also PCI compliant, which means you can actually serve content that contains sensitive information, maybe bank information or account information, back to the users. So what are the usage patterns of CDN? You can deliver your entire website or your web application using a CDN. Of course, you can deliver static content like images and style sheets and scripts, but you can also deliver dynamic contents, which are cacheable contents, and you can also deliver dynamic contents that are personalized, information that is based upon cookies, and information based upon authentication. You can also use CloudFront to distribute software or other large files. For example, if you're Microsoft, or if you're Oracle, if you're some company that delivers software online, so you can download the software from their website, rather than you going to those sites and downloading it, they can use CDN so that you can download the software from the closest edge site. Many software companies actually do that. Even antivirus software, for example, Symantec, they have CDNs all over the world where they have put fingerprints of all the bad malware, so that when you have to do a malware update, you can actually download these large files from these different CDNs. Delivering audio, video, media files. You can stream pre-recorded media such as MP4 and MPEG files. You can also use progressive download of on-demand media. Progressive download is really doing transcoding. For example, you can take a TIFF file and transcode it to JPEG, GIF, and PNG, and depending upon different clients, you can send the appropriate image types. So you can do those kind of transcoding too. We're not going to be talking about that in this class, but it's possible for you to do transcoding. You can also deliver live events. It is possible to do live streaming with CDN. Once again, I'm not going to be talking about that in this class, but it's possible to do that. You can look at the documentation. So how does CloudFront integrate with other services, other AWS services? It integrates with Route 53 for routing requests to the edge locations. We'll talk more about this when we look at the architectural capabilities of CloudFront. It integrates with S3 for serving static web pages. It integrates with SNS for serving alarms. It also integrates with EC2 if your dynamic content is going to be coming from an origin, which is really in EC2. Let's look at the CloudFront architectural components. There are 9 architectural components that I would like to discuss. They are origin server, edge locations, objects, distribution, web distribution, RTMP distribution, dynamic content, cache, and invalidation. Let's look at each one of these components in more detail so we understand CloudFront better. It's important to know these terms because many of these terms are CloudFront related, and we also need to understand how they all fit together so that you can create a CloudFront distribution. Okay, let's look at origin server. We've kind of seen origin server. It's really the server from which CloudFront gets the original object or the original content for distribution. This is the source, the original source of content. Origin can be running on AWS infrastructure. What that means is that your origin can be the S3 bucket, or your origin can be an EC2 web application server. Either one can be an origin, but they're running in the AWS infrastructure. It's very common to use S3 buckets as origins, but it's also possible for you to use EC2 web applications as origins, especially if you're going to be serving dynamic content. The origin can be custom too. In other words, if your application is running in your infrastructure, in your data center, and you can still use CloudFront CDN to serve your content. So they're open to both solutions. A little bit more about origin server. Well, I'm actually using a word called distribution right now, which I haven't really discussed in detail yet. But for now, just think of distribution as the grouping of contents. One CloudFront distribution can have several origins. For example, one distribution over here has an S3 bucket as an origin, has another S3 bucket as an origin, and also has an EC2 instance. Notice I have 1, 2, 3 origins all configured as part of one distribution. And I can say for this URL pattern go over here, for this URL pattern go over there, for a different URL pattern go over here. For example, I'm saying if you see photo/star in the URL, then go to this S3 bucket. If you see thumbnail/star in the URL, go to the EC2 instance. And if you don't see any of these things, go to the default bucket. So there's all these different configurations that you can do for the origin server. Edge locations. We know what edge locations are. We've seen it before when we started learning about cloud computing. We also saw it in the earlier section in this module. Edge locations are really a collection of servers in geographically dispersed data centers where CloudFront caches copies of objects. Of course, we all know what edge locations are, but I'm actually saying you really care about edge locations where CloudFront is a service that's running. It's important to note that AWS may have several edge locations, but CloudFront may not be running on every one of them. So you have to kind of distinguish between the two. As of this writing, they have 30 plus edge locations where CloudFront can serve content. For a complete list of all the AWS Edge locations and services, and the cool thing is that it's available in a JSON format, you can go to this particular URL. Objects. Objects are really a fancy term for your uploaded files or even the dynamically generated content. They can be web pages, images, media files, scripts, or even some kind of a dynamic URL from where you're getting the content. Really, objects are your URLs. That's how you uniquely identify them. These objects can be public, which means these objects that are in the origin can be public URL. So if somebody knows the origin URL, they can go directly and get the origin URL's objects or contents. But they can also be kept private. In other words, you can actually create the origin server and make it available only to the CDN. In this particular case, only to CloudFront. And you can simply tell CloudFront, hey, you have access to that particular origin, but others don't. In fact, you can shut down others. Distribution. A distribution is really an AWS specific term for a CDN instance. If you recall, when we were doing Elastic Beanstalk, we created an application instance. In the same way, when we were working on RDS, we created or launched an RDS instance. In the same way, in the CloudFront terminology, when we create something in CloudFront, we actually create a distribution. We can either create a web distribution or an RTMP distribution. If you create a web distribution, it's really used for static or cacheable content. It's also called download distribution. And by the way, that's what the symbol for it looks like in AWS icons. And all the web distribution domain names start with a D. Take a look out for it. When we actually do the demo, I'll show you how the URLs actually start with a D. So when it comes to RTMP distribution, it's really for streaming content. This is the symbol for the streaming content. For streaming content, the URLs start with an S. So these are the two types of distribution that you will create. When you go to the AWS console, you'll see that you have the opportunity to create web distribution or RTMP distribution. You can launch one or more web or RTMP distributions, just like you can launch one or more RDS instances. The distribution contains configuration information. And when we actually launch it, we'll see what the configurations are. Let's look a little bit more about web distribution. It's used to serve static or cacheable content, HTML, CSS, PHP, PDF, graphic files, all those things are considered to be static cacheable content. The important thing is that with web distribution, you can not only serve the static content, but you can also be a receiver of requests because you can be dynamic. You can add or update using put or post. If you recall, put or post is used to update the content. These are HTTP methods. So when a person in Tokyo posts a form, it can go from client to the Edge site, and from Edge site, it can travel back to your site. You can also delete the objects. So as you can see, they support other than get. They support more than. So it's get plus plus now. The web distribution can pull data from origin, located in Amazon S3 bucket, located in Amazon EC2 instance server, or a custom origin server. Remember I said to you that a distribution contains information. Well, what kind of information goes into a distribution? Information such as where is the origin server? What are the URL patterns, which are also called behaviors, and which URL pattern should go to which origin server? Custom error configuration. What happens if the Edge server receives a request that's a bad request? What is the error message it should send back to the client? Geo restrictions. How can I restrict certain countries from accessing the content? Security configuration like custom SSL, HTTPS. Whether CloudFront should log all the requests. You can ask it to not log the requests. And if you want CloudFront to log the requests, which S3 bucket should it log into? CloudFront uses S3 to log requests. That's where the log files and reports are placed. Also, whether the distribution is enabled. You can enable the distribution or disable the distribution. And also, what are the alternate CNAMEs, which are all the alternate canonical names for that particular domain. There is also RTMP distribution. RTMP distribution is the streaming media content distribution. CloudFront uses Adobe Flash Media Player's RTMP protocol to serve the video and audio files in a streaming fashion. For this, it can pull data only from Amazon S3. So if you're going to be using RTMP, which is real-time messaging protocol, then the video and audio files can only be in S3. It cannot go to a custom origin. So this is a restriction for RTMP distribution. Now let's look at the RTMP distribution configuration. The RTMP distribution configuration is a little bit limited. You can say which S3 bucket to get content from. If you recall, for web distribution, you can go to S3, you can go to your own EC2 server, you can go to your custom origin. Here it can only be S3. You can also do geo-restriction, but it's limited. It uses what is called price class. Rather than selecting the country, blacklisting and whitelisting, you can only do what is called price classes. You can say, I want only North America and South America, or only Europe, or everyone else, or everywhere else. It doesn't really allow you to select countries in detail, at least for now. Security configuration, you can do that as part of the RTMP distribution, so you can serve private content. You can also specify in the configuration whether CloudFront should log all the requests, and if it should, where should it log in S3, that's the S3 bucket information, and whether the distribution is enabled, in other words, it's working right now or not, and what are all the CNAMEs so that you can have custom domains. I cannot emphasize the importance of dynamic content. Don't forget that CloudFront supports dynamic content. In other words, your CloudFront can front S3 buckets, which contain static content. It can also front dynamic content, your load balancer, which has several web servers serving content dynamically. It can also do that, in which case it has the capability to pass cookie and query string information to the dynamic content server and even support post, put, and delete operations into the server. Cache. This is all about HTTP cache. It's really important for us to understand how CloudFront and the browser behave with the HTTP cache headers. If you're going to be serving content dynamically, then you can actually set HTTP cache headers that can be honored by CloudFront and the browser. So let's look at some of these headers. If the origin sends an expires header cache, the expires header cache actually has an absolute time expiration. It tells you exactly when the object will expire. Both CloudFront CDN and the browser will honor that. So if the first request comes into CloudFront cache, it goes to origin, gets the content, stores it in the cache, and serves it back to the browser. The second request may come from a different browser, from a different client. It will go to CloudFront, and the CloudFront can serve that particular content as long as the expiration date has not taken place. Very, very common to do, expires. Max age is another technique. The max age actually gives you time, which is a relative time in seconds. So you can say max age is 60 seconds, which means when your origin serves the content, it can say max age is 60 seconds. CloudFront will cache it for the next 60 seconds. That's what max age is. And the browser can also cache it for the next 60 seconds. They both honor it. Smaxage, S stands for shared, which is really something that is used by only CDN or intermediaries. The browsers actually ignore this header. It's very similar to maxage. The value is given in terms of time in seconds as to when the content will expire. But the important thing is that Smaxage is only used by intermediaries like CDN, only used by CloudFront in this particular case. CloudFront will honor Smaxage and it'll ignore maxage if Smaxage is present. The way this gets used is when you send a cacheable dynamic content through CloudFront, you can set the Smaxage to be a larger value than the maxage. In this way, the browsers can come quite often to the edge site, but the edge site will have the cache for a longer time. So you're actually able to control the cache inside the browser versus the cache inside the edge server. This is actually used for invalidation. If you want to invalidate your content in the edge site, you end up setting smax age. Private basically means that CloudFront will not cache or store anything. Browsers can cache and store. So it's only for the CDN provider like CloudFront. So if it sees a private header, it'll basically not cache it, which is good. No cache, in this case, CloudFront will cache, but will actually check in with the origin. So it'll cache the content, but every time the request comes in, it'll go back to the origin and say, hey, has this content changed? That's what no cache does. No store means CloudFront will not cache anything, but the browsers can cache. There is a difference between no store and no cache. The difference is when it's no cache, CloudFront will store it and cache it, but will check with the origin. Whereas when it's no store, CloudFront will not cache anything and will not even store it. Again, I just want to tell you that this gets quite hairy and you have to actually try these things out in your application to get the best performance. I just wanted to tell you that a CDN provider like CloudFront actually supports all these different capabilities and you can take advantage of it in your applications. Invalidation is the mechanism by which you can remove an object from the edge cache. It's possible to invalidate it, and it so happens that CloudFront actually charges you for that invalidation request, and it may take a few hours for the invalidation to take place. They, I think, allow you 1,000 requests or something like that to invalidate, but after that, they'll charge you money for that. One way to get around the invalidation issue is to actually use versioned name. For example, you may have a logo for your website, and logo is a perfect example of putting something in CDN. You may call the first version of the logo as /images/logo1.gif. If logo changes, then you can change it to /images/logo2.gif, and then you can change your web application to be logo2.gif. In this way, logo1.gif is there in the cache and it'll expire whenever it needs to expire, but logo2 is what is going to be used by the clients, because when they get to your website, they'll be seeing a new link to logo2. By the way, invalidation is a feature that is not available for RTMP. Now let's look at how to configure CloudFront so that it can deliver the content. There are 5 steps. Step number 1, you need to configure your origin server. If you recall, your origin server can be an S3 bucket or an HTTP server. So the developer here is going through step 1 and is configuring the origin server. The origin server can be an S3 bucket. The origin server can be an HTTP web server. The second thing is to upload the content into the origin server. So the developer goes in and uploads the images, style sheets, or whatever the dynamic content is into the S3 bucket or into the web server. Third step, create CloudFront distribution. This is when you go to the AWS console and you create a distribution. You can create a web distribution or an RTMP distribution. Let's go ahead and create the web distribution. You create the web distribution and you configure the distribution and you tell it where the origin server is located. That's what you do. You go to the distribution and you tell it where the origin server is, which is right here. CloudFront gives you the new DNS hostname. When you create this distribution, CloudFront is going to give you a new DNS name. It's going to give you a DNS host name. And that's the DNS host name. Sorry, let me write this better. Host name. It's going to give you a new DNS host name. And that's the DNS host name you have to use in your application. So the developer basically takes the new DNS host name. So as you see over here, the DNS host name is starting with a D. That DNS host name is a D because it's a web distribution. If it was a streaming distribution, it would start with an S. That DNS host name is being given in step 4 back to the developer. The developer then basically uploads his web application. He actually changes the web application to use that distribution name, assuming that the developer uses this distribution name, or they could use the C name. In step 5, CloudFront sends the distribution information to the edge. Finally, CloudFront says, okay, I'm going to go ahead and send all the configuration information to the edge locations. And if there are 30 edge locations, it's going to send the configuration information to all the edge locations. Please note that it is not going to send the content, not the content. It only sends the configuration information to the edge locations. This entire process takes time, especially in RTMP. I've noticed that it takes more time. So please, you have to give some time when you work through this in order to make sure that it's all configured properly. It can be in minutes. It can even take a few hours for the configuration to be distributed across. Okay, so now let's talk about configuring CloudFront to deliver the content to the end users. There are 4 steps to this. The user accesses the HTML website. So the user goes to the browser and accesses the website. That's what is going on in step 1. In step 2, the DNS routes user to the closest edge location based on the IP location and latency. So the user is really going to the DNS server, asking the DNS server, hey, which edge location should I go to? And the DNS server will hopefully return you an edge server which is going to be the closest one, which is what it does. And it does it based upon various considerations. We'll talk more about this in the advanced architectural sections. The client then connects to the appropriate edge server. The edge server will see if it has the content. If it doesn't have the content, as it says in 3a, the edge server will go to the origin, get the content from the origin, store the content in the local cache, and serve the content back to the user. You've seen this a few times before. Now I'm showing you under the context of AWS CloudFront. If you recall, this bucket is the S3 bucket icon. This is your EC2 instance. This is your edge servers. These are your edge servers that are available, or the edge locations to be precise. Edge locations have edge servers in them. And of course, if the next request comes from another user, it'll serve from the local edge location. After an object has been in the edge for 24 hours, CloudFront forwards the next request for the content to validate its correctness. What it really means is when the content is here for about 24 hours, CloudFront, irrespectively, the next request when it comes in, it'll go back to the server, which is the origin, and say, has anything changed? So this is something CloudFront is doing in order to ensure that you haven't set something to be an expiration time of something in the future. It'll never get changed. So in summary, CloudFront is a managed CDN from AWS. CloudFront has several features. It has an admin console. It can serve dynamic content. It has support for post, put, and other HTTP methods for dynamic websites. You can do custom SSL. You can also invalidate cache in the edge sites. It also has wildcard CNAME support, device detection, whether you're using an iPad, iPhone, tablet, and getting reports on them, geo-targeting, targeting content only for users from within a certain country, cross-origin request sharing, which is CORS for cross-domain requests, forward headers to origin, low TTLs, and the TTLs can be as low as 0 for your content, support for cookies and query strings. It can send back those information back to the origin, reporting, custom error messages. So when a bad request comes into the edge site, it can send custom error messages as defined by you. Also security. CloudFront integrates with Route 53 because it uses the Route 53 DNS service to figure out which edge location an end user should connect to. It integrates with S3 because S3 buckets can be the origin. It integrates with EC2 because an EC2 load balancer or an EC2 instance can be origin. It integrates with SNS in order to send alert information. In terms of CloudFront architecture, the origin server is where content originates. It can be an S3 bucket. It could be an EC2 load balancer backed up by several EC2 instances, or an EC2 instance running in the AWS infrastructure. It can also be a custom server running in the customer's premises. Dynamic content can be used as the origin. It doesn't have to be static S3 buckets. Several edge locations are there as part of CloudFront, and they are still expanding. Objects are really content that is static or cacheable, which is what makes it dynamic. Distribution is an instance configuration of CloudFront. So you actually create a distribution in CloudFront. It's an AWS terminology. There are two types of distribution, web or RTMP. Web is used for your normal images and PDF documents or even cacheable document, whereas RTMP is used for streaming video, streaming media, streaming audio. Single distribution can point to multiple origins. CloudFront honors HTTP cache. We looked at several HTTP cache that CloudFront honors. It is also possible to invalidate the cache. It takes hours to invalidate cache. And also, in terms of the CloudFront working model, you as the content provider will configure content in CloudFront by creating a distribution, and this distribution is then copied over to the various edge sites. And then the second part to it is the CloudFront distributing the actual content to the various edge servers so that the end users can have access to it. In other words, CloudFront does not preemptively go and push the contents to all the edge servers. It's only when the user asks for the content the first time, the user is sent to the appropriate edge server, and the edge server then comes to the origin server to get the content. That's the only time the content gets actually pushed. It doesn't preemptively push the contents.